Welcome to the Seaborn Python library lesson. Seaborn is a Python library for making statistical graphics. It builds on top of matplotlib and integrates closely with pandas data structures. Seaborn is used to make plots like bar charts, line plots, scatter plots, and heat maps. People use Seaborn for data analysis, exploring datasets, and presenting insights. Seaborn makes it easy to create beautiful and informative charts with very little code. Real-world uses include business dashboards, scientific papers, and data journalism. Running the cell now. This line will turn off warnings so they do not distract you. If you do not have Seaborn installed, you can open Anaconda prompt or command line and run pip install Seaborn. Now we will import Seaborn with the common alias SNS. We will also import pandas to help with data. We import matplotlib.pyplot for extra plotting. Running the cell now. This initial code sets up the environment by importing Seaborn, pandas, and matplotlib.pyplot, which are essential for creating and customizing statistical visualizations. Although there's no visible output yet, this step is crucial for enabling the powerful plotting functions we'll use throughout the lesson to explore and visualize data effectively. Core objects and concepts in Seaborn. Figure, the whole plot, which can contain multiple axes. Axis, the area where data is plotted, the actual charts. Datasets, usually loaded as pandas data frames. Themes, styles for how plots look. Functions, high-level commands like sns.barplot or sns.scatterplot. Running the cell now. Let us look at Seaborn's built-in datasets. This will print out the list of datasets you can use. Running the cell now. This output lists all the built-in datasets available in Seaborn, which are typically loaded as pandas data frames for plotting. Noticing these dataset names helps you understand the variety of example data you can use to practice creating figures and axes. This step connects to the lesson by introducing the data sources you'll work with when exploring Seaborn's core objects and concepts. Load a built-in dataset as a pandas data frame. We are loading the tips a dataset which is about restaurant bills. This will print the first few rows. Running the cell now. This output shows the first 5 rows of the tips data frame, illustrating the dataset loaded for visualization. Notice the key columns like total_bill, tip, sex, and day, which are the data points we'll use to create plots. This step connects to the lesson by demonstrating how Seaborn works with pandas data frames as core data objects to build visualizations. Beginner example, basic scatter plot. Let us plot total bill versus tip using Seaborn. We will use sns.scatterplot. Running the cell now. Use sns.scatterplot to create a scatter plot of total_bill versus tip. plt.show will display the plot. Running the cell now. This scatter plot displays each restaurant bill's total amount on the x-axis against the tip amount on the y-axis, showing how tips vary with the bill size. Notice the general upward trend, indicating that larger bills tend to have larger tips. This output confirms that sns.scatterplot effectively visualizes relationships between two continuous variables. Beginner example, line plot. This will draw a line connecting all the points. This shows the figure. Running the cell now. This output shows a line plot of total bill versus tip, but since the lesson focuses on creating a scatter plot, notice that a line plot connects data points and may imply trends, while a scatter plot instead displays individual points to show their distribution. To visualize the relationship between total bill and tip clearly, using sns.scatterplot is more appropriate here. Beginner example, bar plot. This groups by each day and shows the average total_bill. Show the plot on the screen. Running the cell now. This output shows a bar plot summarizing the average total bill for each day of the week in the dataset. Notice how the plot aggregates the data by day, giving a clear comparison of typical spending across days. Although the lesson focuses on scatter plots, this bar plot highlights how different plot types can reveal distinct insights from the same data. Intermediate example: grouping by categories. You can color points by another variable using the hue parameter. Let us color the points by the text column. Running the cell now. We color the scatter plot points by the sex of the person. Show the plot. Running the cell now. This scatter plot shows the relationship between total bill and tip, with points colored by the sex to category using the hue parameter. Notice how the distribution trends overlap but slightly differ between males and females, highlighting how grouping by category can reveal patterns within subsets of the data. This visualization emphasizes the power of hue to add a meaningful categorical dimension to your plots. Intermediate example: multiple plots using facet grid. This creates a grid of plots by time new column, lunch or dinner. It maps a histogram for total bill in each grid. Display the figure. Running the cell now. The output shows two histograms of total bills separated by the time of day, lunch and dinner, illustrating how spending varies across these categories. Notice the shape and height of the bars differ between the two plots, highlighting differences in bill amounts and frequency between lunch and dinner. This helps reinforce how to use facet grid for comparing distributions across categorical variables, preparing us to later add hue for additional subgroup coloring. Intermediate example: box plot. This summarizes the distribution of total bill for each day. Show the box plot. Running the cell now. This box plot shows the distribution of total bills across different days, highlighting medians, quartiles, and potential outliers. Although we haven't colored by a sex yet, notice how the spread and center of the bills vary by day, setting the stage for comparing groups once we add the hue parameter. This visualization helps us understand grouping basics before introducing color-coded categories. Advanced example: heat map. A heat map shows data in a grid of colors. Let us make a pivot table of average tips by day and size, then plot it. Running the cell now. Make a pivot table showing the mean tip for each day and table size. Draw a heat map from this pivot. Annotate each cell with the value. Show the heat map. Running the cell now. The heat map displays average tip amounts across different days and party sizes, with each cell color representing the tip value magnitude. Notice the clear variation in tip amounts by day and group size, which helps quickly identify patterns like which day size combinations tend to tip more. This visualization confirms how pivot tables paired with heat maps can reveal insights from aggregated data at a glance. Advanced example: pair plot. This shows all pairwise relationships between columns and colors them by the sex column. Show the chart. Running the cell now. This pair plot displays relationships between multiple numerical variables in the tips dataset, colored by sex. Notice the distribution differences and correlations within and across genders. This helps us understand patterns before moving to more complex plots like heat maps. While not a heat map, it lays the groundwork for exploring multidimensional data visually. Error handling and debugging example. What happens if you use a column name that does not exist? Try plotting something with a typo in the column name. Running the cell now. We use try and except to catch errors. This line tries to plot but has a typo in the total_bil. This would display a plot if there was no error. If there is an error, we catch it. Print out the error message. Running the cell now. The output shows an error message because the code tries to plot using a column name, total_bil, which doesn't exist in the data set. It should be total_bill. This highlights the importance of using correct column names to avoid runtime errors and emphasizes careful debugging when working with data visualizations. Best practices and common patterns. Always check your column names carefully. Label your axes and give your plots titles. Use plt.tight_layout to prevent elements from overlapping. Set a style at the beginning for consistent plots. Save your plots with plt.savefig. Running the cell now. Set the overall style to white grid for better readability. Set the figure size. Draw the bar plot. Set the title for the plot. Label the x-axis. Label the y-axis. Adjust the layout so nothing overlaps. Save the plot as an image file named barplot.png. Show the plot. Running the cell now. The output shows a clean bar plot of average total bills by day, with clearly labeled axes and a descriptive title, demonstrating good practice in plot presentation. Notice how the white grid style enhances readability and plt.tight_layout ensures no labels or titles overlap, keeping the visualization neat and professional. This aligns with best practices for making plots easy to interpret and present. Mini project: compare total bill by smoker status and day. Let us compare the average total bill by smoker and day. We will use bar plots and color by smoker. Add labels and style. Running the cell now. Set the plot size bigger. Use the dark grid style. Draw a bar plot with color by smoker column. Add a descriptive title. Label the x-axis. Label the y-axis. Show a legend for the smoker column. Show the chart. Running the cell now. This bar plot shows the average total bill for each day of the week, separated by smoker status using different colors. Notice how the bars compare between smokers and non-smokers, highlighting trends such as which group tends to spend more or less on certain days. This visualization helps us understand spending patterns and the impact of smoking status across different days, aligning with our goal to compare average bills by smoker and day. Experiment: try your own scatter plot. Ask the user for the x-axis column. Ask the user for the y-axis column. Draw a scatter plot with those columns. Show the scatter plot. Running the cell now. This scatter plot displays the relationship between the columns you chose for the x and y axes using the TIPS dataset. Notice how the points are distributed, which can reveal trends or clusters relevant to factors like day or smoker status. Experimenting with different columns here helps you understand how variables interact before creating more targeted plots in the mini project. Thank you for learning Seaborn. Please like, share, and subscribe for more Python tutorials. Try out other Seaborn charts and have fun with your data. Running the cell now.